Hello everyone, this is Kartikeya Srivastava. I am a candidate master on code forces, 5-star on CodeChef, ITPC Kanpur Mathura Regionals 2020 rank 27, global rank 251 in Google Kickstart round day 2021. And today I am going to discuss the problem fixed points, which was recently asked in October lunchtime 2021. The difficulty level of the problem is cakewalk and the prerequisites are none. So now let's move on to the problem statement. An index of an array A is called a fixed point if the value on the index of the array is equal to the index itself. Formally, an index I of an array A of length n is a fixed point if A of I is equal to I. For example, in the array A, the indices 1, 3, and 4 are fixed points. Chef has an array A consisting of n integers. Chef tries to find the number of fixed points over all the subarrays of the array A. More formally, for every pair L, R, Chef considers the subarray LR and calculates the total number of fixed points in all such subarrays. However, Chef finds his task very hard. Can you help him find the number of fixed points over all the subarrays? So now let me explain you the problem statement in a bit simpler words. We are given an array A consisting of n integers. Now, if we consider any subarray L, R of this array A, then the ith point of this subarray L, R, ith point of this subarray L, R would be called fixed if and only if the value of the ith point is equal to I. Now, the way I would solve this question is basically find the number of suitable subarrays, find the number of suitable subarrays for every index I of the array. So let's see how we will do it. So let's suppose that the value of the element is A of I. Now, in order for this element to be fixed, it should have exactly I minus 1 elements towards the left of it. In A of I minus 1 elements towards the left of it in order for it to belong at the index A of I. Now, if it is having exactly A of I minus 1 elements towards the left of it, then it is belonging at the index A of I. Then this element would be called fixed because A of I is equal to A of I, where A of I is the element value as well as the index of this element in the subarray, which is starting at the index I minus A of I plus 1 and can go anywhere and can end anywhere from index number I to n. So, for an element I to have exactly A of I minus 1 elements towards its left, for index I to have exactly A of I minus 1 elements towards its left, I minus 1 should be greater than equal to A of I minus 1. So, I should be greater than equal to A of I. So, for this element I, the left point of all the subarrays which find it suitable to be a fixed point would be equal to I minus A of I plus 1, and the right point would range from I to n. So for the right point of the subarray, we are having n minus I plus 1 options, and for the left points for the subarray, we are having only one option. So the number of subarrays for which the ith element is a fixed point is n minus I plus 1. And these subarrays would exist if and only if there exists a left point. So I should be greater than equal to A of I for a left point to exist, which is I minus A of I plus 1. If I is less than A of I, then I minus A of I plus 1 would be less than 1, which is not a valid index of the array. So this is how I would find the answer to this problem. Now, what I would do, I would just simply iterate over all the indices starting from 1 to n and take those indices which are having I greater than equal to A of I, which means those indices which can have left indices of the subarray which is fixed and equal to I minus A of I plus 1, and the number of right indices for these indices would be n minus I plus 1. So for all those indices which are having I greater than equal to A of I would add in the answer variable n minus I plus 1. So this would give me the answer for this particular problem. Now let's solve the sample test cases. The first sample test case is 1, 2, the second is 2, 3, 2, and the third is 1, 3, 4, 2. So 1, 2, 2, 3, 2, and 1, 3, 4, 2. So for the first sample test case, yes, I is greater than equal to A of I is 1 and here I is 2. So okay, for this position it is satisfied, for this position it is satisfied. What are the number of right options? It is 2. What are the number of right index options? It is 1. So the answer for this test case would be 3. Here I is not greater than equal to a of I. Here I is not greater than equal to a of I. Here I is greater than equal to a of I. But what are the number of right options? It is only 1. So the answer for this test case would be 1. Now, here I is greater than equal to a of I. Here I is not greater than equal to a of I. Here I is not greater than equal to a of I. Here I is greater than equal to a of I. But for this particular index, there are 4 options for the right index of the subarray. Here there are 0 options, and here there is only a single option. So the answer for the third sample test case would be 5. So this is my approach, basically considering those elements which are having I greater than equal to a of I and just simply adding in the answer n minus I plus 1, which denotes the number of right points of the subarray, which is starting at index I minus a of I plus 1 and ending at any index from I to n for which this ith element acts as a fixed point. Now let's move on to the code of this approach. So here is my code. In this code, T denotes the number of test cases, N denotes the size of the array. Here, A denotes the array. I am taking the array as input. Now, if I is greater than equal to A of I, then I can have a left index corresponding to this element. And I would add in the answer n minus I plus 1, which denotes the number of choices for the right index of the array. After this, I would print the answer. Now let's try submitting the solution. Meanwhile, the submission is being queued, I will tell you the time and space complexity of the solution. The space complexity of this solution is order of n and the time complexity of this solution is order of n per test case. You can see that the solution got accepted. If you have any doubt regarding this approach, you can ask in the comment section. Thank you for watching the video.